Assalamualaikum. My name is Iza Atira binti Ahmad Sirfan.
My name is Nur Shafia binti Abu Bakar. My student ID is 20192588982.
My name is Muhammad Shafrizullah Amri bin Amran. I'm from class J4 EM110-3E.
And we are from group 7. In this video, we're going to conduct an experiment called torsion test. So let's... Don't forget to switch off the torsion test after being used. So this is the differences of experiment and reference for modulus of rigidity, Poisson ratio and maximum shear stress. It does not have much difference but not accurate enough. Possible error is maybe because of the specimen is not tightly enough, the specimen being bent, and at the angle of twist at too rapid a pace. The behavior of this material is a shear stress will equal to the shear strain. It will lead to yielding shear stress and to the ultimate stress and fracture of the specimen. Yes, the Hooke's law for shearing stress and strain is valid. This is because the stress will directly proportional to strain, which the graph of shear stress versus shear strain is in a straight line, but it is only up to the proportional limit of the material. The tested specimen is metal fracture surface with a smooth appearance. The mode of failure under torsion is brittle fracture because brittle fracture occurs most in metals with high strain and low ductility. Hollow bar are able to resist more torque than solid bar. This is because solid bar is stiffer than a hollow bar with the same cross-sectional area. The polar moment of inertia for the hollow bar is lesser than a solid bar, so the resistance to twist or rotate is less. In conclusion, it is proof that we can determine the modulus of rigidity, maximum shearing stress, maximum shearing strain, and Poisson ratio of the tested specimen. The test specimen are brass and steel. The relationship between the torsional load and the angle of twist and shear modulus is achieved. test linearly elastic behavior of the tested specimen is also accomplished.
These are the difference between the result for the experiment and the reference for modulus of rigidity, torsion, ratio, maximum shear stress. Based on the result from the reference and the experiment, the modulus of rigidity is the only value that is the same. However, for torsion ratio and maximum shear stress are different. The value from the experiment is much smaller from the reference. The value from the experiment is smaller. The different values could happen because of the error occurred during the experiment. For example, a systematic error occurred during reading the torsiometer and a random error when the condition of the tested specimen changes during the experiment cause the changes of the atmosphere. Both of the tested specimen changes when the torque applied on it. When the torque is applied, the material will twist to the direction where the torque is applied. One of the things that will occur is the angle of twist of the material will directly proportional to the torque applied. Yes, the Hooke's law for shearing and stress is valid. The Hooke's law is when the stress is directly proportional to the strain, and based on the shear stress and shear strain graph, that both of the value increases directly proportional to each other. After the proportional limit changes, that's where the Hooke's law ends. The appearance of the fracture surface tested specimen was smooth, but the shape of the surface was a bit wavy. That follows the direction of the torque applied and also following the angle of twist. The mode of the failure was a ductile failure under torsion for brass material because it took longer for it to fracture. The steel material was brittle failure because it took less time for it to fracture. The hollow bar would able to resist more torque than solid bar. A solid bar would fracture easily because it has more fill than a hollow bar, and when it has more fill, the resistance is higher and more stiffer. However, hollow bar has less fill, the resistance is lesser and makes it easier for torque applied. Overall, all the objectives were achieved. Got to identify all the information for the tested specimen by using torsion test. Next was torsional load was directly proportional to the angle of twist, and from there we could discover the shear of modulus.
So, firstly, I want to show my result about torsion test. So check it out. Second, the discussion for my lab report about torsion test is number 1. Compare the result of this test between the experiment and reference. Standard value of modulus of rigidity, Poisson ratio, shear stress and shear strain. Comment on any differences and possible sources of error. There are some error on the experiment result, and the cause of the error must be when torsion test is held. The specimen may have some glitch on it, and some error comes in calculation on decimal places. Second question. Describe the behavior of this material as it responds to increasing applied torque. Steel is more hardness than brass, but steel is more brittle than brass. Third question. Is the Hooke's law for shearing stress and strain valid? Explain. Hooke's law is not valid in this experiment because Hooke's law is told about the spring, while this experiment is to measure the hardness of